Okay, welcome everybody to this, our members' images meeting. So just going to run through tonight's agenda. So I've got a few notices to do first of all, then we'll have the main presentation of the members' images, and we'll have a run through the night sky with Richard on the planetarium, the stellarium on the laptop, and then refreshments at the end of that. And if you've got any kit that you've brought along, then put them on the table over there and we'll do the bring and buy. So our next meeting on January the 26th, so it's about 6 weeks away, is going to be Colin Stewart. Now, Colin is a professional speaker, and he's been with us several times before. And he's now going to take us into a completely different topic, a universe of infinities. And basically what Colin is going to talk about is the universe and how infinities play within that universe. So infinity is a very difficult concept, actually. People just know it as a very big number, but actually it's more than that. It's a never-ending number. Colin is going to take that in the context of the universe. So how did the universe start? Did it start from an infinitely small to an infinitely big, or how it's related to that? And then even taking it one stage further, the multiverses. Another question that's asked is, can the bottom of a black hole be infinitely dense? Well, we don't know, I think is the short answer, but Colin will use some mathematics to explore all of this. So you can find out more about that. And along the way, Colin will talk about other things like divide by zero. He might talk about infiniteness science at a circle, which you might think is a circle, but it's actually got infinite number of sides. So if it's a big circle, has it got more sides? If it's a small circle, has it got less sides? Some silly concepts that you mightn't have thought about. And it'll make an interesting talk in the context of our understanding of how big the universe actually is. So I'm going to hand over to Antonio now, because he's going to take you through the next section, which is the members' images. And these are some images from one of the previous sessions. And so without any further ado, I'll hand over to Antonio.
Hello, everyone. I'm Antonio Fillippi. I'm the committee member for astrophotography and joined not long ago. And I took the very interesting challenge to organize a practical deep astrophotography course for the association. This is part of a larger program we have under the name of Bob Gardner Legacy Program. Many of you met him before at the time. Bob passed away recently and kindly left us some money that were to go towards supporting our activity in astrophotography. And he was a keen astrophotographer with some amazing results given the technology that was available at the time. We've been doing this course now since September. The weather hasn't really helped. We had 25 people attending the online theory part. And so far, we had probably 2 sessions at the observatory that were worthwhile organizing. So for those that haven't had the time yet, bear with us. We are trying to find one night of clear sky. For anybody who is interested in astrophotography and wants to look into that, I'm sure we'll do another one at some point, maybe with better weather in spring or something. But even in the meantime, if any of you has interest in astrophotography, please let us know. We are creating a bit of a network and a groups for sharing knowledge and information and learn from each other. We also have an Instagram page, SWHSS Astronomy, which I warmly suggest you follow. If you're not on Instagram, there's a lot of things to be said about Instagram, but for astrophotography, it's a place where you can find fresh images every day, whatever comes out, whatever news there are comets or new discoveries, you can find it on Instagram. And there's hundreds of people contributing every day, including some of the people you'll see today. So without further ado, we show you, first of all, what we achieved with the program we have at High Top. We acquired, thanks to the legacy, some very interesting equipment. You are familiar probably with our telescope and the mount, used up to now mostly for optical usage. We acquired some very good equipment. First of all, a guide camera, which is also a planetary camera. So it can be used for solar, for planetary, and for guiding the bigger kits when we do deep sky astrophotography. And then we have a marvelous ZWO ASI camera, which is a bit of a monster and will be put to good use. And also we acquired a fantastic little product, which is a control unit that allows us to drive all of this through a tablet and therefore make it more accessible, share images, let people see what we're looking at. And we can even do in real-time imaging, so show deep sky objects within 1 or 2 minutes of pointing the telescope at them. It's fair to say we achieved, and we bought new controllers as well for the whole kit. This is an example of what can be done, and it can be done in only 16 minutes of live stacking. So this is something you can show to people in real life, in real time. And then if you take it and progress it further, you can see if you take it home and do some processing, you can eke out even more color and more light and more detail. Equally, 7 minutes only can give you a good view of the Ring Nebula. Galaxies are a relatively difficult target, but with the telescope we have, we can zoom in quite a lot. Again, this is only a few minutes. These are trials. We were probably very out of focus when we took the Orion Nebula, but it's just to show you what is possible in real time. So we have pictures today from David, Andrew, Pele, Stephen, Martin, and myself. So I think I can start introducing David. You want to?
Right. It's been a very poor year for imaging. I keep a folder of all my days spent, or nights spent, imaging. I've been through them in the last couple of weeks looking for images that I can salvage. Very, very few. I spent a long time doing it, but nothing comes out looking at all decent. So what you get here is the best of the rest. This is M33, also known as the Triangulum Galaxy. Bob Garner, previously mentioned. The first night I ever went to see Bob to find out how he did imaging, he asked me, what do I want to look at? And I said, well, let's try M33, because I've never found it. I don't believe it exists. He took an image there and then that night, and well, I was then hooked. I had to get into imaging. This isn't a particularly brilliant image, but it's the best one I've actually done. It's a galaxy in our local group. It and Andromeda are the two biggest members, and they're the closest ones to us, something like 2.7 million light years away. And because it's so close, you can actually see some details in it. You can just see red tinges on some of these things. Here, there's another one there. And those are areas of nebulosity, if you like the Andromeda, the Orion Nebula, but in a different galaxy. And you can only see those because it's only 2.7 million light years away. What you can see mostly are stars in the foreground. The galaxy itself is the surrounding haze without too much detail in it, except, as I say, for these clusters of nebulosity within it. I did 300-second, that's 5-minute exposures, 12 of them in luminance, and 12 at half that exposure, 2.5 minutes, making a total of 90 minutes exposure to get that. Not much more to be said. Next one. This is NGC 488, known as the Crescent Nebula. What this is an emission nebula caused by that star there. Story behind this, and its shape, story behind this is that that became a red giant, and instead of going supernova, it started to shed its outer atmosphere and spat out a vast amount of its mass, which just expanded outwards. Normally, this would just go out into a spherical shape, but this is distorted. And it's distorted because there is a solar wind blowing in this area from elsewhere, blowing like that, that has pushed, collapsed the atmosphere in that direction, and also heaped it up so that it's appearing more dense. Now, what's making it light up is that after it has gone to this explosive state, not explosive state, this extreme size and blown off its atmosphere, very much later, what was left then started to become a very active star and started to emit intense radiation across the spectrum, from ultraviolet to X-ray. And that is shining through this cloud of its former self and causing it to fluoresce. This here is known as a Wolf-Rayet star. And if anybody's interested, look up this. It's quite a nice story about what's happened with one of these. Wolf-Rayet stars are not very common. There are a few around, but this is the most talked about version. What have we got for? This is a narrowband image taken through hydrogen, oxygen, and sulfur filters. Now, the exposure time for this has to be long, because whereas you normally take things in the luminous light, with narrowband filters, what you do is you take a small segment of it. So whereas it was this big, this bright before, you're only seeing that much brightness. So you take a sample from here, and from here, and assign colors to those to bring the colors of this out. The pinks, the yellows, the greens. The colors are rather arbitrary, but they're put in to show the structure of what's happening. The exposures, because of this filtering of the light, these are 10-minute exposures. And total here is 3.5 hours of exposure through the three filters. Next. M3, globular cluster. I don't know how many of you have actually seen a globular cluster through a telescope, but it's a thing you should look at. They're quite fascinating, quite impressive to see. They exist around galaxies. Most galaxies have probably got them. Ours surrounds the core of the galaxy, but outside the galaxy itself. So this is at the distance of 37,000 light years. So it's larger than the core of the galaxy. They have varying numbers of stars. This is one of the larger ones. This has about 500,000 stars. What you're seeing here is most of what you see in there are stars within the globular. The bigger stars that you see scattered around are foreground stars. Exposure for that is quite short because they're quite bright. So that's 30-second exposures, and there are 30 of them, making 15 minutes altogether. Only taken luminosity. There's not much color in globular clusters, so it's a little point in spending time taking the color image. And the last one. A rather poor image of M101. It's one I took in May when it was having a supernova. That is the star that's gone supernova. And as you can see, it's pretty bright. It's brighter than anything else. It's brighter than most of the surrounding stars, which are within our own galaxy. And that is 21 million light years away. So you can imagine just how bright that is. When we get a supernova in our galaxy, it will be impressive. Okay, that's me done.
Andy, Andy's online. Let's see if he can connect and talk us through.
Much like my originals.
Andy, can you hear us?
Yes, can you hear me?
Right, I'll flick pictures for you if you want to walk us through your pictures.
Yeah, thank you. So this is obviously the Milky Way, taken from Southeast Devon in August. It was 20 images stitched together with 20-second exposure, ISO 1600 with a 24mm lens at f1.4. And my other image is from Pitstone Windmill in September, and that's the same lens, just a camera on a tripod, a series of 30-second exposures at ISO 200. That's 120 images layered on top of each other for about an hour exposure. And that's all I have.
Sky astrophotography, so we are expecting way more from you as well on the deeper field. But fantastic, the one with the windmill, I have to say, was surprisingly beautiful. I didn't know there were windmills around here, by the way. So the next speaker is Pele Johnson. Is Pele online or present?
Thank you. Good evening. I'm relatively new here. I've only just joined, so this is my second or third meeting, I think. I decided to take up astrophotography about 4 months ago and did a load of research on equipment and what have you, which arrived about 2 weeks ago. And I've managed to get 6 hours because that's the only clear sky we've had. And this was a test image I did. I did go all out with the equipment, so it's something that I'm going to be serious about going forward, although I've been into visual astronomy for a long time, visual observing. This is the Andromeda Galaxy. I believe it's the furthest thing that you can see with your own eyes from a dark site. It's 2.5 million light years away from us. There used to be a thought that this was about 3 to 4 times the size of the Milky Way, but the consensus now is that it could be roughly the same size. So somewhere between 200 and 400 billion suns or stars. It's about, I think, 2.5 hours of exposure. And that's something like, I can't remember the number, but they were 300-second exposures. I took this on a scope that's got a focal length of 430 millimeters. It's a Williams Optic Zenith Star 73 Mark III, and it's on quite a chunky mount, an EQ6R mount, so it's very stable. This is taken with an Optilong L Pro filter, which effectively cuts out most of the lines of sky glow, lighting, all the stuff that the Earth is currently producing en masse at this moment in time. So it provides a clearer image and gets rid of that. I live in Abbots Langley, so it's a Bortle 6. If you look up the Bortle, you can see where you live and what your Bortle number is. So it's not great for astrophotography, but the L Pro allows you to dive deeper into the sky and see broadband targets. This is considered a broadband target due to the emissions or due to the type of light that's coming from it. So yeah, so that's the Andromeda Galaxy. I'll go to the next one. Ah, there you go. Sorry, thank you. Again, this was a test image, just making sure everything that I'd received in the boxes was actually doing what it was meant to be doing. And this is the Rosette Nebula. It's 5,000 light years from us, I believe. And the span or width of it is about 130 light years across. It's one of the brighter emission nebulas that you can see. And by emission nebula, I mean, this is giving off H2. So this is ionized hydrogen. For that, we use a different filter to capture that light or to cut out most of the light you don't want and to capture the emission light of the nebula. And that's an Optilong L Extreme filter that I was using for the first time, along with all the other gear. And this was processed in actual PixInsight, actually. I've just spent 3 days glued to a laptop and YouTube trying to learn PixInsight. I wish I hadn't because I feel brain dead now. But it does give you a hell of a lot of control. When you take these images, there's nothing on the screen, generally speaking. You have to suck that data out and you have to stretch it and you have to do all sorts of things to end up with a picture like that. But it's actually very rewarding once you've done it and once you see that appearing on your screen. It does give you a good feeling inside. So that's my 6-hour journey so far into astrophotography. I'm just waiting for another clear night. And as soon as there is one, I'll be out all night doing my thing. But I'm more than welcome to bring my gear up to Flaundon or wherever, if anyone else wants to see how it's done. All of the gear is controlled by an ASI Air, so effectively all through a tablet. My camera, my focus, the guide scope, everything is controlled by the ASI Air. So it's a little bit cheating from where we were 15 years ago. So yeah, I'm more than welcome to do that and let anyone else have a look through the scope and see what's coming up.
Thank you very much.
Thank you.
And you're actually welcome to join us whenever we go in a group. We are organizing more and more of these things. So, Pointer, who's next? Stephen Heliczer, please. You're next.
Good evening, everyone. So, yeah. Well, we've seen this already before tonight. This is my version of Supernova in M101. Yeah, it's the closest supernova that we've seen in galaxy in a decade. So, yeah, so I took this 2 nights after it was discovered. This is Cygnus Loop, another very, very popular target. Here you can see the Eastern Veil, Pickering's Triangle, and the Western Veil, which is also known as Witch's Broom, which is that bit there. 2,500 light years away. And it occurred about 21,000 years ago. This is the Helix Nebula. I took this from a dark sky site in the south of Spain with very portable equipment. Very popular target, this planetary nebula in Aquarius, about 600 light years away. Again, Crescent Nebula, also a very popular target. I took this with a, unlike the first speaker, I took this with a one-shot color camera. So I didn't have to muck about with filters. This is just a color camera. But what's interesting is that the technology has advanced so much now that you can actually pick up a lot of data, which was usually, which you didn't used to be able to get, which is this oxygen. I think you can just about see it, this blue oxygen area here. This is the area I really like here. It looks like a loop, the sort of loop you see on our sun. And I kind of wonder whether that is actually an electromagnetic loop in there. Also from my very light polluted back garden. So I also like taking solar system images. So this is one of Saturn, taken with an 11-inch SCT from my back garden. This, in fact, won me a competition recently, UK Cloud Magnets. It was Object of the Month. Doesn't come out so well actually on here, but I was very pleased with this. You can see there's a lot of detail in here. Taken with a ASI 462 camera. I also use WinDupos, which derotates the image, and PIP, which cleans up the video files. I also, this is my first experiment with an animation which shows Io transiting across the planet. You can see it shadowed. And this is probably about 40 or 50 images animated. Finally, this image, which I got a lot of good reception for. This is a montage of 32 frames, 16 of the solar surface and 16 of the edge. There's 160,000 individual stacked images in this image. I took this with a Lunt 80, double stacked with a Quark Chromo filter and an ASI 174 camera. It's the only mono camera I have. The most difficult thing is to get the blends right. I mean, it's a lot easier with the moon, but with the with the sun, it's actually very difficult. And I won. I got Picture of the Month in Astronomy Now, and also an Astrobin Image of the Day. And I even got a £50 check from Astronomy Now, which allowed me to buy a new Takahashi telescope. So I think that's it. Yep.
Thank you very much. Fantastic images. Especially love the rotation. The animation was really beautiful. Martin, Weston.
Always, when I follow Steve, it's always with trepidation because after seeing his images, I'm always frightened to show mine, but I'll take that chance. Okay, so I've known Steve for years, so we go to Spain together to dark sites. So I'll start, hopefully. There we go. So this one I took a couple of months ago. It's the so-called North American Nebula. So-called because this is meant to look like the Gulf of Mexico, and this is North America, and this is the Pelican Nebula. Now, it's actually just one big nebula. This is actually dark material that is blocking the light out from the back of the nebula. So, but you can actually see, I've managed to get some of the detail of that out, because normally it just looks like a big black blob in there, but I've managed to draw out some of the information. Unlike Steve, I only do narrowband, that's all I do. So this was an experiment I did. I've just purchased narrow band filters come in different wavelengths. We were talking about the wavelengths of narrow band. You can get them start at 10 nanometers, and they go right down to 2 and 3 nanometers. The narrower they are, the more expensive they are. So I've had to remortgage my house, and I've managed to get 3 nanometer ones. And this has been taken with hydrogen alpha, oxygen 3, and sulfur 2 in 3 nanometers. I'm pretty pleased with how that came out. Move on to the next one. I'll put a little bit of information there just about the nebula itself. So it's 16,000 to 4,000, 1,600 to 4,000 light years distance. Astrayard is what I call my back garden, by the way. This has been shown, so I'm not going to talk too much about it because it's, as was explained, it's a Wolf-Rayet star. Quite like this subject myself. The only difference, I suppose, Steve's done his in the colour, but you can use different palettes with narrow band. I've used what's called the Hubble palette because it tends to bring out a bit more detail. But again, you can see the oxygen envelope around this. So this one here is the famous Eagle Nebula. I'm glad I've got something that's not been shown so far. So, and if you look in the center there, you'll see this familiar pattern here was a big image that Hubble took called the Pillars of Creation, because this area here is a star being born. So I took this in Spain when me and Steve were out there earlier back in September, but I think we got about an hour and then the clouds rolled in, so I didn't get very much data on this. But later on, I did. So I managed to get a closer look at the center. Again, you can see the Pillars of Creation here. A bit more detail. I've actually taken the stars out. I do that mainly so that when I start enhancing the image, the stars can go a bit funny colors and so forth. So when I'm more interested in bringing out detail, I tend to just take the stars out. There's a bit of information there, closer view of the pillars. Blue colors of the image represent oxygen, red is sulfur, and green is nitrogen and hydrogen. So it's 4 to 5 light years, that area there we're looking at. The Pillars of Creation, fascinatingly, relatively small feature of the entire, but as you saw earlier on, you can see the whole nebula. Yes, so I took that in EI in Spain. Again, the only difference, Steve's shown this, is Helix Nebula, but the only difference with this, his and mine is I've done mine through narrow band, he's done his through colour. But again, you can see, I will talk a little bit about this because it's not been mentioned, but this is what can occur when a sun like ours, star like ours, reaches the end of its life and expands into a red giant, and then eventually it throws off all its material, and what's left of the core of the star condenses down and becomes a white dwarf, which is what I believe that is there. And that actually lights up the nebula. It's actually the radiation from the white dwarf is causing the nebula to glow. Again, this one, Steve's done this already. This is supernova remnant. I won't go on that too much. Not as good as his one. So this one here, it's actually an image I took, I think last year, but I've reprocessed it. I've took the stars out and I've tried to bring out a bit of the detail. It's a part of the California Nebula, which again is quite a bright and quite a large nebula, star forming. Again, I've used narrow band. These are the 3 nanometer filters. So this again, I've just done a little bit of work with this one, but it's not come out very well. But it's the Horsehead Nebula, which is in Orion. And this area here is just dark material, which is blocking out the light. from the stars behind, but it looks very much like a horse's head. Lastly, I just thought I'd just show you a bit of information about what I've got. So I've got two main rig setups. This is my home setup on an EQ8. I've got, that's a 10-inch RC there. And on the back, I've got a Sharp Star wide field. So I tend to do, if I pick a target, I'll do a wide field view of it and I'll do a closer up using QSI mono cameras. So here we've got one QSI camera here. There's another QSI camera here, but this is my, I use off-axis guiding, so that's my guide camera there. I've got a Pegasus power unit there, which I use to distribute the power, and it's not there at the moment, but I've got a small computer, mini computer there, which runs the whole thing. And I actually don't go out there. Once I've taken the cover off, I sit inside and my Wi-Fi. So that's my homes kit, and that's my travel kit. So it's an EQ6, Vixen 103mm refractor, and again that's the Sharp Star, and that's us in Spain, and that was taken by Steve, and that's my lot.
Thank you. Right, the last speaker is me. So this is a collection of pictures I collected in the last 6 months. I was lucky enough to spend the summer in Italy, in my hometown, which is a Bortle 5, so decent weather, decent light pollution, but also to spend a few days up in the Italian Alps, in the Dolomites, where I originally come from, and convinced my wife there was this fantastic hotel with a infinity pool. I didn't tell her that the owner is a astromaniac and he has 3 observatories at the back of the hotel. And I was lucky enough to spend time there. So this is one of my equipment. I'll show you my pictures by equipment used. What I'm actually using for the next few pictures is this little thing here. That is not my guide scope. That was my main telescope for some of the pictures attached to this camera here. So swapping cameras. Typically, my equipment is this AM5 mount, which is an harmonic mount, very portable. A deep sky camera that can get cool to -10 or -20 degrees to avoid noise from heat. And then controlling everything with the AZR and a tablet, and a selection of telescopes. So with the smaller of the telescopes, you go very wide field, so you can take very wide field targets. And this is my version of the Crescent Nebula and the clouds around Cygnus. This is about 5 hours of pictures, so 5 minutes times 60, more or less, at a relatively good speed of 4.6. So a fast telescope to collect light. And you see all the nebulosity and the, oops, apologies, I'm flipping it through. On the nebulosity around Cygnus. So it's a summer target, fantastic target. And I got shortlisted for a competition in Italy and on show in the local science museum. The next picture is the Cygnus loop. Again, this one is probably 2.5 hours roughly. This is a supernova, so it's the outer shell of an exploded star. You've seen it probably before once at least. This star exploded around 20,000 years ago, if I remember well. And there's a lot of detail, and you see red is oxygen, green, blue, sorry, red is hydrogen, and green, blue is oxygen. And I take all my picture with a color camera, and I develop them. Sometimes it takes me 5 hours to take a picture and 2-3 hours to develop it properly. But I try to keep as close to the original colors as possible. So what you see here is what you would get to see if your eyes could collect that much light. This is, again, a wide field view of the Bubble Nebula here, which we'll see probably later again, and the Clo Nebula, and a few other clusters, and a open star cluster. Again, about 5 hours taken from the Italian Alps. This is my mid-size telescope, so the white one this time, this one. Same gear. I use it natively as it comes, or I put an adapter that makes it more wide field and much faster collecting lights. It sort of makes it 4 times faster. So 1 hour is like 4 hours with the original telescope. And this is my 5 hours on the Andromeda Galaxy, taken from the Italian Dolomites. It's actually not 5 hours, it's probably 2.5, 3 hours. We've seen it before, so this is my take. Done with no filter, actually. The place was dark enough, and you could barely see it with your naked eye from where I was. It was 1,600 meters high, very, very clear skies. This was taken actually from Greece. I travel a lot to take pictures, and it's a very interesting target because it's 3 nebulas in one. In red, you have an emission nebula. So this is hydrogen excited by some stars and emitting lights. In blue, you have the reflection nebula. So this is just the dust that reflects the light of the nearby stars. And then in between, you have this very dark nebula, which is essentially very dark dust that blocks the light. And so you cannot do this with a narrowband or narrowband filters because you would lose half of the target. And you need really to go without filter or with a very broadband spectrum filter. And it's interesting also to see how many stars there are around and all the colors. Same target, but even more wide field there, and with the Lagoon Nebula down here. Again, taken in Greece about 3, 4, 5 hours roughly. That's typically my comfort zone. Below, things are too noisy. Above, the weather or the travel doesn't allow me to do it. This I like because it's different. This is Barnard 150 or the Seahorse Nebula. And unlike all the other things you've seen so far, it doesn't emit any light. This is just dust in a very interesting shape, and clouds that really subtract from the background that is very dense, is stars in the Milky Way. Barnard is a catalog of hundreds of these dark nebulas, very difficult targets, but very interesting to find and to picture because they're different. Again, nebulae insignias. Again, in this case, you have red hydrogen emission, so very bright, and reflection in the middle, so you cannot use filters. And therefore, I had to be in a dark site and use a good 5 hours. Cygnus Wall, so this is a part of the North American nebula you've seen before, just zoomed in, and you can see quite a lot of nebulosity and detail. Again, probably around 4 or 5 hours. And the Elephant Trunk, this is a target that is, very near polar, so you can see it's a good part of the year. But when it goes to the, when it's at the highest, is always the best to target it. This is only 3 hours, 5 hours again. So with a relatively fast telescope. And then again, with this telescope, Bubble Nebula in detail, so zoomed in. You remember before it was a small target, now you can see it much more in detail. So the Bubble Nebula is again one of these stars that blew out their outer shells, and then the remaining star in the center radiates and makes the outer shell that is still expanding, makes it visible and radiating. And on top of that, this specific nebula is sort of placed within another emission nebula, so it makes it like looks like a pearl in an oyster or something very, very similar. This was taken from near Lake Como, again in my family travels. And another 5 hours target at a relatively good speed of telescope. Again, this taken from the center of town in Bortle 4-5. It's the Triangulum Galaxy, and as someone pointed out earlier, you can see the details and the star formations area in here that are, in another galaxy, which is mind-boggling. And then I did a big jump recently, only 2 months ago. I took my Celestron telescope, which is normally a telescope for very small object, very detailed views, long focal length. And I converted it to a thing called the hyperstar. That makes it look funny because the light, instead of coming out at the back, goes back at the front, but makes it very fast. What it means is that an hour with this telescope here is like 10 hours with the telescope I've shown you before, and 25 hours like if I were to put the camera back here. So that allows me to make the most of the very, very desperately awful weather we had in the last few months. And here is the outcome. This is the Hart Nebula. This is about, again, around 5 hours, I think, if I do the maths quickly. But this was taken from central London, Bortle 9, with an Antlia filter, which is a 5 nanometer filter in red and hydrogen and oxygen. It's still quite surprising what one can do from absolute, zone 3 in London. But I think the star of the game here is the detail you get out of the hyperstar arrangement, because you can see how much I can get out of it. And the next picture is the California Nebula, again from central London. This was my first try, so could do better probably. I'll go back to the targets, but I think still you can see quite a lot of detail. And the Rosette Nebula, the reason I put this picture here, which is not that great, is to show the power of the telescope. This was done with 20 minutes. So this is only 20 minutes of a picture with the hyperstar. I have similar pictures that took me 5 hours with the other telescope. So I could do the most of like an hour or so of clear weather from central London. So this is taken from central London in 20 minutes. This is another target I want to go back to. This was taken for London. So as I said, as part of the network we created with the event, with the course on astrophotography, we have a little group, and sometimes we go out. And this was the last time we were out. A couple of the members, Andy was there. I stayed, it was a very windy day, so we couldn't get much done. I stayed up and between 4 and 5 in the morning, the wind was a little bit quieter. And in, again, 40 minutes, I got to take the Jellyfish Nebula, which is sort of north of Orion, and a very, very faint target. And finally, again, from London, about 5 hours, definitely 5 hours. This is the Soul Nebula, so it's the companion nebula to the Hart Nebula I've seen before. And again, quite happy with the level of detail. It's all red because, as I said, I don't play with colors. These are the one-shot colors that come through a color camera. I just use the filter to filter out the noise and the light pollution. This was a very long, cold night in London, but quite happy with the results. I think we are done with members' images. Thank you.
Yeah, so that's pretty much it for tonight. Thanks ever so much for all those that have contributed. And as ever, the standard is going up and up and up, and the technology is moving along so that we can image in shorter time scales. But I've got to make a special mention to Pele, who's only been doing this for a very short period of time, and to produce 2 images like he did for tonight, I think was amazing. But the whole thing about a society like ours is that we share knowledge, and that's why we started the astrophotography course, to help people get on the ladder. And we showed you some poor images, our test images from high top. But from that point onwards, you learn how to do it and you perfect it. It's not an easy skill to learn, but it is very rewarding when you get the results that you're looking for. So again, I would like to thank everyone that contributed to tonight to make that a success. And Richard is now going to take us through a little bit about the night sky coming up in the next month or so.
Okay. Well, this is the December meeting, and usually talk about things like Orion, nice comforting objects, which I'm going to start with, but I also want to try something else, that go a little bit deeper into something completely different. Now, we've heard mention of Barnard objects. Barnard was a very, very dedicated guy. He came from an extremely poor background and was born just after the end of the American Civil War. He taught himself astronomy, and he became the foremost visual observer of his time. He was very, very, very good. But he turned his attention to photography, and he became a very, very good photographer. And he spent quite a few months photographing the sky with a special camera, and it was on a mountain in California. And when he first started observing, he was frightened of the animals that were around, because there are all sorts of wild animals up there. But over time, he began to really enjoy these sessions. And the amazing thing about it was that when he didn't know what he was going to find, when he took the picture, the plate, the first thing he saw of the objects that was actually in the developing dish. He didn't know what he was looking for. I mean, these days we take pictures and we say, oh, we're taking a picture of the Orion Nebula. He didn't know any of that at all. And he was very interested in these black objects that he couldn't really understand, what they were. And that's how he came to catalogue them. And they are all sorts of shapes. So Barnard was a very, very prolific character. He worked himself virtually to death. He had diabetes and he died in 1923. But he had a very long career, very, very dedicated. So we're going to start off with Orion, because obviously Orion is coming up at the moment in the evening sky. Now, I want to say a little bit about Jupiter as well. Now, Jupiter, I haven't had a chance to see recently. For the same reason that most of us have had trouble. Basically, the sky has been too cloudy, and when it was clear, the seeing was so poor that I couldn't really see much of an image anyway. So it's still around, and it's still up there, and it'll be there for another couple of months, and I'm sure that it will get better opportunities later on in this opposition, and which will last for a long time. If you want to see Saturn, you really have to go out just after sunset, because it's quite low now in the evening sky. So then we come on to Betelgeuse. Let's see if I can move that along a little bit. Yes. Now, Orion, two brightest stars, Betelgeuse and Rigel. They are complete opposites in types of star. Betelgeuse is a red giant. It's a very big red giant, actually. And a couple of years ago, it caused quite a stir and a few people to be a bit anxious, because it started to dim down. That has since been that we understand why that happened. Astronomers have worked out that it was dust clouds, because it produces a huge amount of dust. If you could talk about a source of pollution, Betelgeuse would be one of them, because it pumps lots of dark stuff out, because it's so cool. But it seems to have settled down again. And you keep coming on across these theories about, oh, it's going to go up soon, it's going to explode, it's going to do this. Astronomers are not that convinced, and we could be waiting for quite a long time. The opposite star, which is Rigel down here, is in fact much the brighter of the two stars. If Betelgeuse is about 450 light years away, Rigel, the distances are a bit uncertain here, but it's certainly over 900 light years away. So of the two stars, it's definitely the brightest. It's also a very hot star, and it has a diamond whiteness, very, very intense in a telescope. It has a companion, the star which is called the Pup, because obviously, sorry, it has I'm getting ahead of myself here. Rigel has a star that you can see visually, but it's very, very difficult. I used to see it quite regularly, but now, because the conditions are not so good, I've not seen it so much. but it is there. It's right on the edge of visibility with a small telescope, mainly because Rigel is so bright. But it's a very, very bright star. It's pumping out its energy at a furious rate. Now, obviously, we have the Orion Nebula, which we've been seeing pictures of, and we all know what it looks like. But sometimes it's just as well to have a look occasionally, just to see if it's still the same. It will be, but you sometimes see new things when you come across something again that you haven't looked at for a while. So it's interesting to have a look at it visually, take pictures, etc. And notice the trapezium, the 4 stars in the center, the fish's eye, the fish's mouth part of the Orion Nebula. Now that there are 4 stars, but technically there are more than that. Now there's E, D, and F. The brightest ones are A, B, C, and D. Then you've got E, F, and G. Sorry. Now F is impossible. I have seen E once or twice with my 8.5-inch reflector, but it's worth having a look. If you've got a large telescope where you've got clear night, have a look for this star E. If you see the parallelogram, it's between 2 of the stars, and you just suddenly come across it. If you gaze at them very carefully, you can see this little dot of light that's E. And that's much fainter than the others. A multiple star that's in Orion is this one here. That is Sigma. Now Sigma is actually 5 stars, and they're in kind of 2 groups of stars. It's like looking at 2 sets of double stars. But they're all slightly different colors, and that's interesting. In fact, it's such a good target. When I have my 90mm refractor, I used to periodically have a look at them just because it was a nice sight. So that's something that you can have a look at, and it's relatively easy to find, because obviously you've got the belt stars here, so you can't really miss Sigma down here. The star here, which is at the end of the belt, that's Delta of the 3 belt stars. This one is almost precisely on the ecliptic, and also it's a double star, very nice double star. You can see it in binoculars. Actually, it's not too difficult. It's quite a hard job in binoculars, but a bigger telescope will show it very easily. Now, the star I was talking about with the companion was this one here, down here, Sirius. Now, the belt stars make a direct line down towards Sirius. Sirius is the dog star, and it was worshipped by the Egyptians. It was actually used for a very serious purpose for them, because they knew when the Nile was going to flood, when Sirius rose with the sun. So it's really a very important star to them, because they knew the Nile would flood, and that would enable them to plant their crops. So this was really not astronomy for education or whatever. This was astronomy for living. You had to know that, and they didn't know when the Nile was going to flood. They could probably guess by a few sort of things in the environment, but they knew that once they saw Sirius rising just before the sun, then that would herald the rising of the Nile and the flooding out towards the Mediterranean. So this is more or less the sort of point at which we end talking about the summer, the winter sky and around Christmas. There's 1 or 2 other interesting things before we move on, just for a couple of minutes. You see these little three stars here. Well, those 3, one of them is actually Iota Orionis, and that is quite a close double star, but it's also a very hot pair of stars. It's extremely hot. It's right at the top of the A group of stars, B being so I'll get this right. O are the very hottest, and B is just below, just a little bit just cooler. So it's right at the top of that particular group, and that is unusual for having two very hot stars close together like that. And you can actually see them with a small telescope. And that marks the head of Orion. And if you think about it, the moon, we always think of the moon as being quite a large diameter, or certainly, reasonable size, but it would actually fit in those three stars if you could move it to that position, which of course you can't, because it's on it goes along the ecliptic, and of course Orion is not one of the constellations on the ecliptic, not one of the zodiacal constellations. Now I'm going to move around a little bit, and we're going to go completely off thing here. So I'm going to put the guide things on so that we can see our constellation guides. So we're going to be moving up and I'm going to try and do. It's funny, I did this afternoon and it worked fine. There we are. Now, in the west at the moment, high in the southwest, you'll find the constellation of Cassiopeia. This is it here, this W. That's Beta at the top. That's Alpha. And this one down here is a very, very attractive double star, which is Eta. But I particularly want to use this to point out some objects in a constellation that we don't normally think of. This thing that looks like a child's drawing of a house upside down is actually Cepheus. Now, Cepheus doesn't really come into conversation very often, simply because it's dim and there's, it's not really that attractive. And after all, there's a lot of objects you can see in the Milky Way, which is in this area here. So it doesn't tend to come up very often. But it's a very important constellation, and there are some interesting objects in it that are worth looking at. For instance, this little triangle of stars here. Now, the one in the point at the apex, if you want to call it that, of the triangle, is actually a star. It's Delta Cephei. Now, it's actually a very nice coloured double star. In fact, you can split them with a pair of very good binoculars, and you see a little blue star next to the yellowy star. But there's more to it than that, because in the early 17th century, a guy called John Goodricke, who was a deaf mute, discovered with his friend Pigott that that star actually varied. And it varied in quite a precise way. It had a fast rise and then a drop. A rise and a drop. So he didn't know what could cause that, but he wrote it down. He made sure that and got people to observe it. Sadly, he died at the age of 22, which was a great loss to astronomy. And actually, his friend Pigott was really upset by this, and he gave up astronomy for about 6 or 7 years because it reminded him too much of his friend John Goodricke. But there's more to the story even than that, because in the late 19th century, Henrietta Swan Leavitt was a lady working at the Harvard College Observatory, and she was actually looking at these variables, which are called Cepheid variables, in the Small Magellanic Cloud, and she realized something that was very important, and that was that you could use these stars to get distance measurements because you could tell how bright they were. It's a complicated thing which I won't go into to explain, but it's very important, and a lot of modern astrophysics is based on this. Cepheid variables are a yardstick into space, and she wrote in 1912 a paper where she explained this idea that she had, that it could be used, and it would be a good idea to do that. It did get published, and of course the person that took most interest in it were two people. But one of them was Edwin Hubble, and he used that method to use that yardstick to work out the distances of galaxies in the outer universe. In fact, his measurements were out of scale by 100%. But the point was that he was the first person to be able to do that, and he credited Henrietta Swan Leavitt with that discovery. The fact that, funnily enough, she was also deaf, and she also suffered from cancer, and she died quite early on. But so there's a lot on that star. There's a star here which is also very important. That's the Garnet star. Garnet star that's what Sir William Herschel called it. It's actually a very, very, it's an M-type star, which means it's cool, it's red, but it actually has water vapor in its atmosphere because its atmosphere is so cool that you can actually get steam from a star. But that is one of the most beautiful things to look at. Have a look at that, and you get a real indication of colour in the sky. There's also a double star in Cepheus over here. That's Beta, and Beta is a star with a little companion. And if you're doing digital imaging, etc., this whole area here is interesting for nebulosity. And also there's a cluster with a spiral galaxy next to it. Now I've seen the cluster, but I've tried and never actually seen the face-on spiral next to it with my 8.5-inch telescope. So you've also got another couple of double stars in there that are on the Struve catalogue. So there's a lot of interest in that one little square where you'd think there was not much there. So that's something, comparing it with Orion, where you've got a huge amount of objects and all very bright. There's an area there that kind of hides away and you don't notice it. By the way, it's Cepheus. Cepheus was Cassiopeia's husband and Andromeda's father. So he was a king, but he's not as important as his wife because she's much more easily to find. Anyway, so I was going to leave it there, and we'll come back to this in January when we'll be looking at the constellation of Gemini. I've also brought along, just to show you, anything that you want to look at in the sky. I've got this very handy book. Now, I used to have atlases, but I gave up to some extent on atlases because they're cumbersome. This thing has even nebulous areas and all sorts of stuff in it. Sky and Telescope's Pocket Sky Atlas. It's very good. I know that most people don't need to use it these days, but for if you're out looking at the sky, I've got a pair of binoculars, have a look, use that as well. It's very good. And it doesn't need batteries, which is even better. Thank you.
Thanks for that, Richard. And that ends our show for tonight. And all that remains is to wish you all a very happy Christmas. I hope you have a great time and a break over Christmas. And we'll see you again in the new year in 2024. Thank you very much and good night.